Good morning, ladies and gentlemen. Welcome to Kaduna State Senior Secondary School's online connect, powered by Exponential Computers. Physics lesson for SS1 students. Week 4. That is the fourth week of the physics lesson or physics class. I, the presenter, Ismail Baraya. So for the fourth week or the week 4 of physics context. So here are the contents. The contents, it says heat transfer. So last week we talk about the concept of heat and temperature. So for the week 4, that is this week, so we are going to talk about the heat transfer. And the heat transfer, it contains the conduction, the convection, and the radiation. So let's go and see. Heat transfer, that is the content. Okay, so before we even start, so we talk about heat, that is at week 3. So even if you are not around, when we say heat, normally heat is a form of energy, and that energy is called a thermal energy. So heat is a form of energy. So we are talking about the transferring of that heat, how that heat is transferred. So let's see. So heat energy may be transferred from one point to another by any of those three modes, that is conduction, convection, and radiation. So a heat, it can be transferred within these three, and these are the conduction, the convection, and the radiation. So heat can only be transferred within these three, and it can transfer from one point to another point. So and the direction of heat transfer is always from hotter to the cooler part of the solid. So you see, a heat, it can only be transferred from the hotter to the cooler side, and a heat cannot transfer from cool to hot. So if it from cool to hot, that is not heat. So but if it is from hot, that is from the heat, from the temperature, so it is heat transfer. It transferred from the hot object or particle or solid. It transferred from hotter, that is, or hot, from to cooler, that is from the cool side. So this is how heat transferred. Heat transferred from one point to another, but only within these three, that is the conduction, the convection, and the radiation. So heat can only be transferred within these three modes. So let's go and see what those three modes says about how heat can be transferred. Okay, so the first one among them is the conduction. So conduction of heat is the process by which heat energy is transferred through a material. The average position of the particles of the material remain the same. So let's look at this definition. It's talking about how heat is transferred within the position or within the particle, and that particle, it will remain the same. And when we say something will remain the same, we are talking about it will be it will be at a constant. It will not change in side or in length or in something. It will remain at its side. It will remain at constant, at its own value. It will not change. But as you know, if you put something on heat, maybe a rubber or something like that, if you put rubber on heat, it will change its size, because it will it will turn into a tiny size. So you see, a rubber cannot remain at its same size, but due to the conduction, it will remain at its side. So if it remain at its side, so that means that at its size, so that means that it is conduction. So a conduction of heat is the process by which heat energy is transparent through a medium, you see through that medium heat will be transparent. So you see, even it is different from that one, it will be transparent through it, through that medium, that heat will be transparent. The average position of the particles of the material remain the same. So you see it will remain the same, and also that heat will be transparent through it. So this is about how the conduction is. And the example of those materials that can be conductivity of heat through it, it is the first one, it can be a copper. It can contain heat because it can pass through it. Also the aluminium is also, the heat can be transferred through it, and it will remain the same, the size will not change. So also the silver also heat can pass through it, and its size will remain the same. And also iron, so you see those ones, they can contain heat, and the heat can be transferred through them easily. So they have the material, they can pass the heat can pass through their material medium through easily, they can be transferred through them easily, and their size will remain constant, it will not change, their size will not change. And this below here, if you look at this diagram here, it's trying to show us, or it's trying to tell us how the conduction is. So it is this thing that you are seeing. Let's take an example of it, like it is a metal, or it can be a copper, or aluminum, or silver, or iron. So let's say it is an iron, and here like it's a candle, and there is fire, is heat, or fire, or temperature, something like that. So let's consider it fire, and you are putting that aluminum or silver or copper on it. So that thing, and if you can remember in the definition of conduction, it will remain the same. And you see, if you put it on fire, it will remain the same at its size. So, and due to that remaining, the heat can be transferred through it. So if you see, if you put that iron or silver on heat, it will remain the same, and the heat will start transferring, it will start going until it reaches maybe at the end of the silver or the iron. So you see, maybe it will pass through the whole medium, it can pass through the whole medium in a time, with a time going, it will pass slowly, continuously the heat will keep transferring through it, and the size will remain constant, it will not change. The size of the medium will be constant, it will not change, or the size of that material will not change. So you see, due to that transferring, due to that conduction or conductivity, the energy, or the heat energy will pass through it, and it can remain constant, it will not change. So if you have this condition, that means that you have conduction. So heat can transfer through that medium, and that medium will remain the same, it will not change its size. So if you have that kind of thing, that is conduction, as simple as that, because the material, the energy can pass through it, and it will not change. So you see, when you have that kind of thing, that means it is a conduction. And there are some materials that the heat cannot pass them, and that one is like a rubber. You see, a rubber, heat cannot pass it cannot pass through, the heat cannot pass through it, and its size will not be the same. So you see, if you have that kind of condition, the heat will not transfer through it. So you see, it will change its size, and maybe turn into a tiny side, it will melt. So you see, that is not the conduction, that is not a conductivity. But if you have the remaining of the size remain, then heat can pass through it. So when heat pass through it, that means that you have a conduction. So this is about how conduction used to take place. So the second one is the convection. Okay, and the convection is the process by which heat is transferred in a liquid or gas by the actual movement of the heated fluid from the hotter to the colder part. So let's look at the definition and see. You will see that we have it transferred in a liquid. So you see, when we see something liquid, that means that it is not solid and it is not gas. So you see, it is a liquid. And also by the actual movement, the movement of the heated that fluid from the hotter to the colder part, or to the cooler side. So this is how convection used to take place. This is a process by which heat is transferred, but it transferred only either in liquid form or in a gaseous form. So not in liquid, well, no, not in solid. It is in liquid and gas, and by the actual movement of the heated or that heated fluid from the hotter to the colder part. And if you look at this diagram here, this diagram is trying to show us how a convection used to take place. So you look, if you look at it, this it is a kettle containing of a water or a molecule. So you see, it is containing a water, and below here we have heat, or we have a fire, or a fire that is heating, maybe let's say the water. And if you look at it, this green one, it is a water, and it contains some molecules. So you see, due to that heating of due to that heat from that fire that is getting, so that water, the molecule on that water will start maybe like rotating or boiling or something like that. So you see, it will start changing. Before you put it, it is a cool water. The water is cool. So due to that heat that you are getting from that energy, that thermal energy, the cool water will start rotating or moving. Not only even rotating, it will it will start moving, the actual movement of the heated, yes, from that heat. Then those molecules will start rotating, will start moving from the cool molecule to the warm molecule. So you see, this is how they will be changing from they will keep changing from the warm molecule to cool molecule, from the warm molecule, because when you are heating it at the bottom of the let's say the kettle, the water there, the down there, the water, it is trying to be hot. So it will start, but the off one, the top, the water at the top, it is cool. So they will start rotating from the hotter side to cool side. So if that situation continue to do the rotating, at the end of the day, that water will be hot. The total of it, all of the water can be hot due to that heat energy or thermal energy that is heating that water, that is heating that molecule. So this is how the convection used to take place. It's the process by which heat is transparent in a liquid. So it is transparent in a liquid form. So or in a gaseous form, by the actual movement of the heated fluid from the hotter to the colder part. So you see, this is how the convection used to take place. And the last one among them is the radiation. So radiation is the process by which heat is transferred from a hotter to a cooler place without heating of the medium. So if you look at it, this one look like it is the simpler one. It is transparent from a hotter to a cooler, but only without heating of the medium. They will not be in contact with each other. So the transparent will not be in contact without even heating of the medium. You are not touching the object or the particle or the water. No, it will not like that. The radiation is not like that. Without even touching, that is how the heat used to be transferred. Also from hotter to a cooler. So if you look at this diagram, it's trying to show how the radiation used to take place. Like maybe like if you put a fire, like we have a fire here, but if you come close to that fire and wait for some seconds, you will find out that your hands will start to gain warmth due to that heat, due to that radiation that is coming from that heat energy, that is coming from that thermal energy. Even you do not even touch that fire, so you see it is due to radiation. Or maybe like in your room, when it is a cool weather, you will put a fire in your room. So you see at the end of the day, the whole room will be warm. Why is it warm? Because of that radiation. The heat will keep transparent without even touching the medium. It will not touch the medium, it will transpire. So you see, unlike the conduction, because the conduction has to be in contact with the object, also with the convection. But this one, the radiation, the heat is transparent from hotter to a cooler place without heating the medium. They will not be in contact with the medium. That is how the radiation used to take place. Just like a natural example, like a sun. So you see, if you see a sun, when there is too much sun, when there is sunlight, when the sunlight come out, you will see that if you come and stay, if you stand straight, so you see the reflection of the light will start getting on your body, on your skin. You will start to get heated. So it is due to that radiation. You are not in contact with the sun, so you see, but due to that radiation, your body will start to get warm. Or maybe even if you are feeling cold on your body, then when you come out, so you see, and if there is too much sun, so you see, you will find out that you will cool yourself. You will see it is due to that radiation. It will transpire without even touching the medium or the particle or the object or the body. They will not be in contact, and that heat will be transparent. So this is about the radiation. So, and this is the whole explanation of them. This one is called the heat transfer, how the heat come to be transparent. So if you look at it, there is a conduction here, we also have a convection here, and also the radiation. So this is how the heat used to come to be transparent. So that, let's say the hand of this pot, so you see, it is from the heat, due to this radiation, this hand of a pot, because it is metal, the heat will start getting there, and when it gets there, it will start moving, and at the end of the day, the whole pot will be hot. So this is due to the conduction, and also due to this heat that is getting from this fire, from the energy, or this thermal energy. So the water will start moving, will start rotating, or will start even escaping. So you see, and I told you, it can be in a liquid or in a gas. So you see, like if you look at this thing, like it is like a gas trying to escape. So it is those molecules, so they are like trying to escape. And also in a liquid form, the water will be hot. It will start going from the hotter side, the bottom of the pot. It is hot. The water down in the hot, it is hot. So, and the water in top, it is cool. So they will start rotating, they will start moving continuously. So you see, and at the end of the day, the whole water will be hot. So this is how the heat used to be transferred. And this is the radiation. So you see, even the radiation and the fort and the firewood, they will not touch each other, but due to the radiation, how close they are, so it can start to get warm. It will start to get warm. Yes, due to the radiation from the heat that is getting. And a heat is in a form of energy, and that energy is called thermal energy. So this is how heat transfer is. This is about heat transfer, how heat transfer used to come to do. Heat cannot be transferred without these three. That is the conduction, that is the convection, and the radiation. So these three come and bring and form a heat transfer. This is how heat transfer come to be. So this is about heat transfer. So thank you for listening, and this is the end of the fourth week or the week for this class or this lesson for SS1 student. So I wish you good luck.